Okay, so let's make that sim itself. So I'm going to say source here. Go back to the first frame. Put a dot network down. I'm going to hook it into the first thing. If we dive inside, what do we need? We're going to use a sparse simulator again. So say, start off with a smoke object sparse. Then we're going to need a pyrosolver sparse. Put that into the first input. We're going to need gravity. You might be tempted to say that we need a ground plane, but we're not going to do that this time. We're going to actually be doing a lot of the collisions ourselves. So the solver itself, or rather the object itself, has this boundary conditions where we can just say treat the y closed below a certain amount. So as you might imagine, y equals 0 is the ground plane. So below 0 it is closed. Now we don't need a ground plane anymore. Even better is if we take the voxel size. So copy that parameter and then paste it here and say y equals 0 minus that, which really is just negative that. I want to give it one more voxel below here, because I know from experience that if we make y equals 0 be the ground plane, you might have a little bit of a gap, just a tiny little bit of gap. That can be strange, and especially because our camera's so low to the ground here, we might see that gap. So all I want is give me one more voxel to go below the ground plane, and it'll just make it feel like the smoke is resting on the ground just a little bit better. Easy enough to do. The solver itself has dissipation on by default. I mean, we will end up adding dissipation, but just while we get everything sorted, let's have that off. And we need to actually source our stuff in. So volume source can hook into our sourcing, which is the third input there. So it's one of those nodes where I wanted to do initialize smoke, but because it's already set to it, you have to set it to something else first and then come back to it so that it actually does it. So it's going to look for a density, a temperature, and velocity field. We don't have temperature, so I'm just going to go ahead and delete it. But it does exist. We certainly could have temperature. This is like an exploding thing after all, but there's going to be enough roiling and movement around. Most of the movement in this is going to come from the collisions moving through it anyway. So I'm just going to turn it off for have less variables to juggle. So what gets sourced? Well, our first context geometry, because we plugged it in there, is going to be our source. If I press play, you might recall that that usually won't work by default. What you need to do is say enlarge fields to contain sources, like so. That way it will actually say, oh, is the actual source outside, because this is the simulation area here. And seeing as our initial smoke is coming from up here, it won't find it. So just remember to turn that on so it does find it. Sweet. So it's adding it in, and it all is technically working. It already looks kind of crazy, but we can see the mushrooms kind of forming here that we don't really like, but it does at least tell us that it's technically running. So I'm going to save it. So jump out here, and I don't see it. So we need to do import fields, and we want our dot network to be the dot network. We can just point to the smoke object generator inside of it, like so. And now I can just say, well, what do I need? I need my density. So again, we go to one of these frames that it exists, and we can see it. And we also need the velocity, which is vel, and we'll make it invisible, kind of like how we did before. In fact, we can just do a volume visualizer here again after this and say, just show me the density, and now I can also just play with what it looks like after the fact too. Cool. What else can we do while we're out here? Well, now that we have our sim running, this is actually a decent kind of resolution. The default of 0.1 was pretty good. It just so happened to be pretty good for our sim at this scale. So like looking at this, and I look in here, this sim is 200 by 200 by 300. It's not a terribly high-res simulation, but it's a good jumping off point. It's certainly enough that we can copy this parameter and jump out here, and let's make our velocity rasterized attributes, the voxel size, be in terms of that, so paste relative references. So if and when we do increase our resolution later on, we'll get it here too. We don't want to have our particle scale to be the same. Now, it just so happened that our particle scale was the same as that. But remember, this is just the size. This is just the size in world space. So even if our resolution of our sim gets more refined, we want our particles, the space that they represent, is a fixed amount. So keep the particle scale the same. The voxel size, though, for the density, I often find myself doing that actually as half, meaning a higher resolution input than the sim itself. That way the sim can sample in a high resolution thing and make sure that we don't lose any resolution. If we make the voxel resolution the same as the sim, but the sim's grid doesn't overlap exactly where the incoming volume is, you might lose a little bit of resolution. It's not really something I've talked about too much because it's like, it doesn't really change that much, but this is one of those, like, technically, if you can afford it, and you can see how fast it is rasterizing this anyway, we're not losing much by making this have twice as much of a resolution. So just keep it there and sleep easier at night knowing that you're getting the best possible input into your simulation. Sweet. So now that that's all set up, I'm going to say on my sim, again, if you can afford it, go to your cache memory. I like to just have this higher so I can keep more frames in memory while I'm working on this stuff. The memory is this. It's this blue bar that fills up. By going from 5,000 megabyte cache to a 50,000 megabyte cache, I'll be able to have 10 times as much stored in memory. Won't make a difference if you're just going to cache it to disk anyway and look at it, but it can be nice to just quickly and easily do it here in the viewport. So just a thing. I'm going to turn on the building in the background again so we can start to see what's going on here. Let's flipbook this. Let's flipbook some of this anyway. I'm not going to wait for it to finish the whole thing. Okay, so that's probably enough. I'm going to press escape on this. So it's enough to see a few things. One is that, I mean, it's going crazy fast. That's because of all the velocity that we're adding in. And remember, we're adding it in on every frame. So it's kind of going faster and faster and faster. We don't really need to add that much velocity into this. So first things first, let's just turn it off. Most of the velocity that we care about is going to come from the collision anyway. So even when we turn this additional velocity back on, let's go put it to 0. When we turn this back on later, we're only going to turn it on like a little bit. The other thing that we needed to do is, right now, there's no limits to this. You know, it's going to keep increasing our simulation field as it expands. And while it is a sparse solver, so we get, you know, a good memory efficiency where we're not going to store anything in all this blank space, nonetheless, it can still get out of hand. We have a voxel size, but no limit on how many voxels we can have. So really we should turn on this max size business here to say, we love what you're doing, sparse thing. We love that we can have a much higher resolution sim than we would otherwise have, but we still need to have some boundaries. So I'm going to make an arbitrary box here. The box, more or less, can be a thing that's going to define kind of like what's fair game. Kind of like the way we hollowed out our building before. We're not as interested in the smoke in the back here. So I want to like kind of bias it towards what's closer to the camera. So something like that. I'm going to say this should be like 45 by 45, and it can be 30 high. So that's pretty much right. And let's kind of center this like so. Seems like we still have most of it over here. And if we look down the sides, I mean, if the smoke comes all the way to this front wall, it still might look weird, but this is a good place to start from. And in any case, nope, turn that off. One thing you might notice is it's 30 high, but the center is at 14. So typically, we would have like this be 15 so that it's resting right on the ground. But remember in here, I told it I wanted to have the ground plane be 1 voxel below. So I just want to have this be below even that to make sure that the smoke doesn't run out of the domain before it even gets to that ground plane that we set up. So the point is just that I want the bottom of this box to be below this value here, which don't know why it's not evaluating it, but it is just going to be the negative of this. That was really strange. Why does it look like doing that? It's almost disconcerting. Yeah, strange stuff. All right, well, it seems like I'm getting like a weird viewport bug. I'm not going to dwell on it though, so I'm pretty sure that's going to be fine. So we set up this box. So copy the parameter of the center of the box and paste relative references into the center here. Turn on max size. Let's copy the size here and come in here and paste it. So now we won't really see it. I mean, we saw the center get updated, but rest assured, a box that is defined by a center and a size, it will be correct. So now when we run it, it should be totally fine. Sweet. We could cache it, but I don't think we really need to. I mean, again, we turned the velocity off, so we're not really going to see that much of anything interesting to cache yet. If I just scrub this, you'll see it's just adding density, but nothing is moving outside of that. Cool. Moving on to the thing that actually will make it move, collisions.